Hi, welcome to the tutorial on data exploration, independent numerical variables. By the end of this topic, you will be able to explain and perform variable transformation. List the questions one needs to answer while exploring numerical variables and answer them. So we'll continue our journey of understanding and preparing our data for modeling. And next step would be to explore and pre-process all the numerical variables in the data. Let us first recall raw_housing_data.info code that can help us identify all the numerical variables in one go. Sale price is our target variable, which we have already explored. The variable ID is a reference number assigned to a row and is not a house characteristic. Hence, it will not be used in analysis or model building. Excluding these two, we have 15 numerical variables present in our dataset as listed on the screen. Now, before we start analyzing these variables in greater detail, let's learn about an important concept, variable transformation. Variable transformation refers to the process of making changes to a variable in a way that it becomes more useful and meaningful for analysis and modeling purposes. There could be several reasons due to which you may wish to transform a variable. Let's discuss some of them. Variables are transformed for outlier treatment. Previously, when we mentioned that we can take a square or cube root or logarithmic of a variable to treat outliers in it, that is nothing but an example of variable transformation. Another situation when a variable type needs to be changed is when the variable does not represent the information it contains in the best possible way. For example, the variable zip code contains the area pin code where the house is located. While this variable is indeed numeric, it is hard to imagine any numerical relationship between zip code and sale price. Not only it is possible for two consecutive zip codes, say 98002 and 98003, to actually belong to two different parts of the city and not two adjacent areas, the house prices in these two zip codes may vary quite a bit depending on the locality they represent. Think of how pin codes are allotted in your city and whether two nearby pin codes always represent two nearby areas, or whether two nearby localities have a similar house price, and you would understand this better. However, while house prices may not vary as per a set numerical pattern with zip codes, it is indeed possible that house prices in certain zip codes are higher than others depending on the locality, and hence it would make sense to convert this variable data type into a categorical variable where we can analyze sale price in each zip code and see if there is a variation across zip codes. We write the code to convert this variable's data type and to verify. Let's check the data type once again for the zip code which we have converted. On the other hand, look at the variable number of times visited, which represents how many times a house may have been visited and is recorded as a categorical variable and contains values like none, once, twice, etc. Given the nature of the information this variable contains is numerical, it would make sense to record this variable as numerical variable, so that if there is indeed any relationship between a house's sale price and number of times it was visited, we can extend that relation to all other numerical values also that may not be present in the data, say 5. Now we can recode this variable like this, where we first find out all unique values present in this variable and then replace them with their corresponding numerical values like this. Let's first check the unique values for this variable. For that, we write the code as shown on the screen. We will recode them into numbers using the pandas.map function. For this, we will first have to create a mapping between the old and the new values. We will do this by defining a dictionary called mapping. So let's define it. Once the mapping is defined, we will use the pandas.map function and pass the mapping into it. So let's do it. Now that we have changed the values to numbers, let's check it using the .unique function. And here they are in numbers. Another reason of data transformation is to derive a new variable from an existing variable, or combining two variables to transform a variable so that it becomes more useful. Let's look at the variable renovated year. This represents the calendar year in which the house may have been renovated. For example, value of 1991 represents the house was renovated in the year 1991, and value of 0 represents the house was never renovated. Intuitively, this does seem like a useful information that may impact the sale price of a house. Now, other than whether a house was renovated or not, what other information about renovation do you think can impact a house's sale price? Yes, you may want to ask, how long ago was the renovation done? A recently renovated house may fetch a higher price in the market than the one that was renovated 20 years ago, right? Hence, we would like to derive two variables from the variable renovated year. Whether the house was ever renovated, let's call this variable ever renovated. And how long ago was the renovation done? Let's call this variable years since renovation. Now for the first variable, ever renovated, we derive it by assigning yes, whether the variable renovated year has a non-zero value, and no, whenever the variable renovated year is 0. As you can see, this would be a categorical variable. After deriving the variable, we add it to our dataset. To do this, we will use the where function of the NumPy library. So we write the code as raw_housing_data ever renovated equal to np.where raw_housing_data renovated year equal to 0, no, comma yes. Understanding this code is simple. Wherever the value of renovated year is 0, it assigns the value no to the variable ever renovated. Else, that is, wherever the value of renovated year is not 0, it assigns the value yes to the new variable. Now press Ctrl and Enter and the variable gets transformed. Let's see the changes in the data. For the second variable, years since renovation, we will extract year of sale from another variable, date house was sold, and subtract year of renovation from it, which would give us the years since the renovation at the time of sale. For houses that were never renovated, we can assign 0 as years since renovation to represent that they were never renovated. This would be a numerical variable, and we would add this new column also to the dataset. First, we have to fetch the year from the date of sale variable and name it as purchase year. So, let's write the code and fetch the year. Next, for the duration since renovation, we create a new variable which will be calculated as discussed earlier. So let's write the code as raw_housing_data years since renovation equal to np.where raw_housing_data ever renovated equal to yes, absolute value raw_housing_data purchase year minus raw_housing_data renovated year, comma 0. Now press Ctrl and Enter and the value gets calculated. Let's check the values in the data. Now there is just one step remaining. We have used the variable date house was sold to get the values for the variable purchase year, and then used the purchase year variable and then the renovated year variable to derive the third variable years since renovation, which we would be using for our analysis and model building going forward. Just to keep our dataset tidy, we can drop the other three variables, which are date house was sold, purchase year, renovated year, from our data since we would not need them going forward. We drop the variables using the drop function. So let's check the code for this. Since we will be removing the entire column, we take the value of axis equal to 1 in the drop function. We first write the name of the dataset and then write the name of the column which we will drop from the dataset. Now let's execute the code. The three variables are dropped from the dataset. Now I hope you have a good understanding of variable transformation. There are a few more situations in which we transform a variable, and we would cover them subsequently as and when we come across such situations. For now, let's get back to analyzing the numerical variables. Based on whatever we have discussed so far, we now have this refined list of 15 numerical variables that we would analyze. Just like we did for our target variable, questions that we usually seek answers to while exploring numerical variables are shown on the screen. The modified dataset that you should arrive at after treating missing values and outliers for all these 16 numerical variables is given in the helper text below, and this dataset has been named as transformed housing data. From the next video onward, whenever we refer to transformed housing data, we would be referring to this modified dataset. For now, let's import this dataset into our Jupyter notebook after placing this in the working directory like this. So that's it in this tutorial.